We were in discussion with Hadoop components, and we have two components in Hadoop, HDFS and MapReduce. And we've seen more services are there which are responsible to store the data, and two we are using to process the data. And what are the name? So I'll write it again. Within HDFS and within MapReduce 2, and I'm writing specifically MapReduce 2 because there is MR1 and MR2. MR1 is for Hadoop 1.x, MR2 is for Hadoop 2.x. Okay. Now in HDFS we have name node, data node, secondary name node. Within MR2 for process, this is a storage area and this is processing area. Here we had resource manager, and please read them in a daily basis, because otherwise if you skip one day reading also you'll forget the whole idea behind this. And while implementing this concept, will be using this all functionality, where what is the use of this service, how we are aiding this, what property we are aiding this. Okay. So I'm not saying to remember all the properties which I'll be adding for name node, but what is the use of name node? That should be very, very clear. What is the use of data node? And likewise for all the services. Here we have node manager. Now, which one is the master here? So Hadoop is driven by master and worker methodology. So name node is a master, data node is a slave, secondary name node is again master, resource manager is master, and node manager is slave. What is name node and what name node does? What is name node and what name node does? So name node is a master in the cluster. Okay, name node is a master in the cluster, and it maintain all the metadata. It maintains all the metadata. In Hadoop 1.x, we had one limitation within this name node. In Hadoop 1.x, name node is known as name node was a single point of failure. Single point of failure. What do we mean by single point of failure? So here's a picture. Always use a graphical scenario to understand the flow between client and your server. Okay, then this thing makes your concept very, very clear. So client is there. Okay, client is there, and this is name node. This is name node. So as we know, client wants to read or write anything. First, it is requesting to master. We know name node is a master service, and master and slave is working as the same thing. That let's say let's take example of here one IT organizations, right? In IT org, what happened here when your client is giving 4 different tasks? This task uh, this task could be development, testing, administrations, architecture. This is given to project manager, right? Then this project manager will check this task. He will not start writing by himself, right? Because he's managing multiple projects. It's not that just one client project is taking care of it. What client does, what PM does, project manager does, project manager will distribute this task to their resources. So let's say 3 people are reporting to this guy. this PM. There are person 1, person 2, person 3. And since he's a project manager, so he knows that P1 is good in P1 is good in development task, P2 is good in testing, and P3 is good in some miscellaneous activity. Okay. So out of this 4 tasks, he will identify which task can be done by which person, and PM will assign that task to respective people, right? And along with that, he will ask, what is your ETA, estimated time of arrival? How many days will you take to complete the task, right? Now, P1 will say, let's say 2 days, 1 day. So I'll complete this in 2 days. All the development activity, whatever is given by project manager. This P1, P2, P3 is not directly talking to client. Neither this client is directly talking to P1, P2, P3. This guy is working as a mediator, right? If you focus in this middle area, this guy is working as a mediator, getting information from here to there, and once they complete their job, so P1 after 2 days will complete the task, 1 day, whatever time. So I'm just assuming this time, okay? Whatever time this people have decided to complete, let's say this is 0.5 days. So they'll acknowledge back to project manager. That's what we do when you get any job from your manager, that I have completed this, and now my bandwidth is free. You can give me some other task also, because I have got a time now. Now this PM will revert back to client, and this is how the thing is working in IT organization, right? Now, who is PM? What is the role of PM? PM role is exactly working as a master, and this P1, P2, P3 is nothing but their 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 worker, because they are taking all the responsibility, all the task from PM, completing based on their given ETA, given time, and once they complete, they acknowledge back to project manager. Then this guy gives the same output to client for the testing purpose. The same thing will happen between client and name node here. Same thing will happen between this client and this name node. So here, where we are storing this data, where we are storing this data. Data node I will cover separately. First let's focus on the name node. So there is my client, there's my name node, and there are several data nodes we have: dn1, dn2, dn3. These are just a metaphor. This whole scenario is just a metaphor for what design we are understanding in as a part of Hadoop storage. So client requested, this request can be anything. This request can be read request or write request. It can be anything. Now, name node is maintaining what? Name node maintain all different metadata. Now, if you ask me what is metadata, so metadata is a data of data, or one data talks about another data. Just like one plain example, if I give you, so you guys have seen a book, right? If you open a book, at first page you found content, preface. Then when you go to actual page, that 40 number page, we have this topic, you found the data. So whatever is written as a content, as a preface, that is nothing but your metadata. One data talks about another data. Now all this information is with name node. Now, when name node knows that you can read from this machine, and how they're deciding which one is going as a first priority to client, which node will be the first priority for client. So we have seen there data locality. In our last class, if you remember, we have seen this concept of data locality. What they try to do, they try to write the information at nearest machine. Nearest machine, we are mapping with whom? We are mapping with the client. This client is calling from which location? Let's say this client is calling from Sydney to write some information, right? Now, first preference here, DN out of DN, DN1, DN2, DN3, Whichever machine is near to this location will be preference. Then based on their location, we are giving them in a ascending order. Name node is not writing. Similarly, this guy is not doing the task. This guy is just assigning the task. So name node will give this information back to client. Now client will start writing this information to this machine. This is how the flow will work. Okay, we'll see when our cluster is ready and we are trying to write a file. So when we are trying to write a file, how the request will go, and after getting acknowledgement from the master machine, how the copy thing is happening. Look, in picture you cannot see this. Your job is to just run a command, just like in Linux operating system we have seen the Unix command. When you're writing this command, let's say you want to copy some file, so you write cp stand for copy, then you give source and destination. Do you know what is happening in behind? Your job as a developer or as a Unix guy, your job is to just run this query. Now when you're running this query, do you know what is happening inside? So this is what all happens behind the picture. So I'm explaining you here what is a metadata. Metadata is data about data. Okay, and name node role is very specific here. Name node role is very important. That is why we are saying that if name node is down, if this name node goes down, your entire cluster is down, because all this communication is happening through whom? All this communication happening through name node only. So if name node itself is not available, we do not have this metadata also, then how can we know which machine is near and which machine is not near, or where to copy the file, or from where to read the file? Many questions will arise when this is down. So there is a fixed error. If this is down, intentionally we can kill this name node and we can see what problem is coming once our cluster is set. Okay, so when name node is down, you will get oftentimes that client node is unable to communicate to this IP. Client machine is unable to communicate to this IP, and you will see IP of this machine. If this service is down, this is how we will monitor and manage our services. Okay, now here you can understand this client as one more example. Let's say you're new to the city, you're new to Pune. Now when you want to purchase a iPad, let's say, or you want to purchase a mobile. Since you're new to the city, you don't know anything about which shop to go, where is the area, you're nothing, you don't know anything about this city. Now what you decide to visit a mall. When you decide to visit a mall, what happened there? There's so many shops, still you don't know which shop to go. So you visit a receptionist, front desk, where it is written as may I help you, right? So you visit to this receptionist. This receptionist will give you what? Number of list where they have got a mobile shops. So maybe they'll say you can go to third floor in this mall, and you can get Chroma. You can go to fifth floor, and you can get a Vijay cells. Likewise, number of lists they can give you. Will this receptionist go along with you to this shop to purchase the mobile? They are just sitting there to provide you information. If any customer is not able to understand where the shops are located, they are helping you. The same way this name node is doing. Client comes to this, ask where to read and where to write. Name node says, okay, let me check where this data is located and where which machine is near to you. Then I will provide you that information. Same thing as this. So we can, in a way, we can call this name node as a receptionist. This is a receptionist in the Hadoop cluster. So whichever information you want to receive, you always make a request to this name node, guys. Okay. So in Hadoop 1.x, we have made a first point that name node is a single point of failure. What do I mean by this particular statement, single point of failure? If this machine goes down, you cannot do anything. cluster is shut down. When your cluster is shut down, it's a downtime scenario. And whenever it is a downtime, you know that you're losing a business, because downtime is production cause. You can't do anything whenever you see any downtime. If you have seen that, many times when some server goes down of this big companies, WhatsApp, Facebook, we often read this in the newspaper, right? That this was down for just 20 minutes, and how many business they lost, because people are not able to communicate. Simple. And if they're not able to communicate, their business won't grow. This is first point to discuss about name node. Second point, we made that name node is taking care of metadata, all information about the cluster. That's what we call a metadata. And metadata has a two type. First type is FS images, file system images. Okay. Now, FS images is a snapshot. FS images is a snapshot, just like human memory, human brain. Machine also has a brain, so that is a machine brain. Whenever you shut down your machine, let's say you worked from 10 a.m. to 11 a.m., and 1 hour information is there in a form of metadata, so that we call a snapshot. I can give you one practical example. So we all have VMware installed in our machine, right? VMware, Oracle VirtualBox. So if you open your VM image of Ubuntu or Cloudera, okay, so when you open a image of Ubuntu, check their size. Their size is daily increasing. Today, let's suppose their size is 403926 byte. Okay, I'm just taking this random number. Let's just take this number. So this is the byte of current VM which I'm using. Today, you start that, work for 2 hours, do some activity, run some command, and again close them down. So you will see there the size is increasing every day. That is nothing but that's your snapshot. Okay, so snapshot, technically we call it a file system image. We can see them. I'll show you all of this information, but they are not readable. They're not written in English. You cannot make any sense. They're written in binary form. Okay, and sequential informations are there. Second metadata type is edit logs. Edit log is all activity which you're doing within the Hadoop cluster, all sort of activity. Okay, activity, when I say copy, delete, change, permission, grouping, request, ownership, any kind of command you're running, that is getting stored in your edit logs. So in Unix, we have seen such command. We have seen kind of this command, like if I want to copy something, what I do, I run a command cp space source space destination. I'll give path of this. If I want to move anything, what we do, we use command mv, then again source, and again destination. If I want to delete anything, what I do, I write rm and then file name. This is all command which you're doing. This is nothing but what, this is your activity logs. This is your activity logs which are getting stored in edit logs. So combining this two file, fs images and edit logs, we call it's a metadata. All right, guys. So point number third for name node. Any question you feel to ask here? These are very important point. Okay, this is a very important point uh, to discuss about the name node, and while setting the cluster for name node, that how name node works. How do they know the information about entire cluster? So we know name node is a master, but why we are calling name node as a master? That point we should be clear with. Third point is a rack awareness. Is a rack awareness. Have you heard about rack earlier? What is rack? So rack is not only available, or this term we are using for Hadoop. This is uncommon. Like we have not only talking about rack in Hadoop. We have seen this in data center and server also. Okay, so let me write the hierarchy first. How do we manage the rack? Now you have a data. You have a data, and data, when I say it can be any information, a structure, unstructured, semi-structure, uh, text data, audio, video, images. This is all we call a data. Maybe you guys can give me your email ID and phone number. That also I can call as a data. So this data is getting stored in data node. This data is getting stored in data node. Data node is getting stored in rack, and rack is getting stored in data center. Remember this hierarchy, guys. Okay, this is how your hierarchy works. Whatever data you are keeping, it goes to data node. Data node we will manage in rack, and rack we will manage in data center. So I'll show you one rack, how actually rack looks in physical. How do we see any rack? So I'll search for data center. I'll search for data center, and I'll go with this images. Let me open this image. Can you see these big boxes? What are this? This is all. You're saying this looks like Almira, that very big, and we're keeping as our belongings. This is nothing but it's your rack. So here we are combining. This is all the location where we keep our data node. These are the area where we keep our data nodes. This is one data center. So data center is obviously a physical location. Uh, Amazon Amazon is having in Mumbai. So in must be in Mumbai, they have some location identified that where to keep this data center, right? So this is all physical, and we keep these places very cool because the whole set of bunch of information is there. This is like company whole data, last 200 years, 300 years whole data. Whole business is running from here only. Okay, so this is how do we manage the information. This is a server room. We can call this as a server room. So how rack concept will work in Hadoop? This is my rack 1. Let's say this is my rack 1. You can create n number of racks. Okay, but again we have slots available in RAM, just like we have machine with a configuration 4 GB RAM, 8 GB RAM, 10 GB RAM, 16 GB RAM. So based on the cost, you can get a better configuration. Similarly, we have this rack also. Some rack has a 3 slots available, 10 slots available, 5 slots available. So we can configure it accordingly. Now this is my rack 1. This is my rack 1, and it's a off rack and local rack. So we call this rack as a off rack and local rack. I'm creating 2 different rack to understand how the whole copy thing will work. And in this point, I will answer this question: why replication factor? Why replication factor is 3? Why this value is 3? We have seen in a Hadoop features, right? What is the Hadoop additional feature? So we know that replication factor, we are copying any data 3 times. So when I say replica means cloning and duplicate of the data, exact copy of the data. So we're copying 3 times, but we had a question: why 3? Why not more than 3? Or why not less than 3? Okay, this is configurable. But number 3 is a strategic solution. This is a strategic solution. It's not fixed that we will have to keep this only, but expert or people who started working with this multi-node and parallel processing concept, they said 3 is giving us the best result. You can increase it to 4 also, but that would be unnecessary. You're not utilizing your space properly. So this is what will prove here why replication factor is 3. This is my, just bear with me, I'm a little bad with the drawing. This is my rack 2, and this is my remote rack. So here we have a slots available. Here we have a slots available. Let's say this is slot 1, this is slot 2. Similarly, this is slot 1, this is slot 2. And here I will keep my one data node. This is my one machine. This is my one machine. This is my another machine. And this is my one more machine. Okay. And let's copy some data. And this machine is data node 1, data node 2, data node 3, because that's what we said. In Hadoop, your metadata is managed by name node and data you are copying in the data node. So data node is meant for data only. And all this data node is having, let's say 200 MB of data. Here we have 200 MB of some data, 200 MB data, 200 MB data. And why I'm writing 203 times? Because replication is 3. If I'm losing this node or maybe this rack, so I have the same data available in DN2 and DN3 also. If I'm losing this rack 2 also, I have my rack 1 available from where I can read the data. And I'm doing this whole bunch of process to achieve 3 things. First, no downtime, no downtime. Because if I have copied this data multiple time and anyone is getting down, my machine is not immediately going to downtime. I have other copy available from where I can read this. Second, load balance. Because simple concept, guys, be logical. If I give you 10 tasks to one person only, so obviously their load will be high. It's better that I should divide this 5 tasks and 5 tasks to 2 people. Or maybe if I have 3 people, I will divide 3 tasks and 4 tasks. So I'm trying to balance the load. That's why I'm not giving the whole set of requests to one person or one machine. Third is a parallel concept, parallel processing. Okay, so if multiple client wants to read the information, one client can request there, second client can request there, third client can request there. And how the sorting is happening based on the data locality. Always remember this data locality thing, that client location is very important. Always we map the server with a client, that this client is near to which machine and where it should write the file or from where it should read the file. Now, if I'm losing data node or if I'm losing rack, I have a solution. And all this rack is stored where? This is all stored in one data center. So we know this data is getting stored in data node. Data node is getting stored in rack. That's what we said. This is my data. This is my data node. This is my rack. And rack is getting stored in data center. But what if you lose this? So you have a solution. If you lose data node, you can read it from other rack. If this rack is down, you can read it from this rack. But what if this whole data center itself is down? Then what will happen? You lost all the data. Just like if this is just one data center and I lost this entire data center due to any reason, let's say there's a huge flood, okay, natural disaster happened, and I lost all the data center. If I lost all the data center, simple, I lost my whole business. Okay, that's the reason in production we never take such risk. What we do in production, if this is my data center, and this is one more rack, which I'll say rack n. Okay, and here I will keep one more copy, one more machine, and here I'll keep my data. This is my DN. Okay, this data center is known as a DR data center. This data center is known as a DR data center. If you ask me, DR abbreviation, DR stands for Disaster Recovery Data Center. Disaster Recovery Data Center. And from where this is getting data, guys? What do we do in production? This is not applicable only for Hadoop. I'm repeating again. This picture is done. This whole configuration is done by administrator to to achieve this downtime, balance the load, and to achieve this parallel processing. They use the similar concept in many different technology also, and many different framework also, not just Hadoop. Data center is this is a production data center. So this data center is giving their backup in every 10 hour, and again this is configurable. I can change it to any number. This is configurable. I can change this number 10 hours to 24 hours, 10 days, 20 days. It depends how sensitive your data is. If you're working with such a sensitive or very important industry where your data is very very important, that you need a backup in every 1 hour. Okay, so then you can increase this to 1 hour. So we can change this number. Now data center is giving all their backup in every 10 hour to DR data center. So if anything happen with this, we have this DR data center available, from where again we can recover our data. So once your project goes live on production, you do not run any query on this DR center. If any problem you're facing or your client is facing, you're not disturbing this, because if you disturb this data center, your DR is also disturbed, because DR is ultimately taking all the backup from where? From DR data center, from data center only. That's the reason if any production issues is coming, so we always run a query in this box, because this is having all the data available. This won't be counted under replication 3. Okay, your replica is, this is first replica, this is second replica, this is third replica. Now you can argue that if I give four replica, this if I increase this value from 3 to 4, what will happen? Right, what will happen? So if you have one more data node available, currently I have just created 3 data node because replication is 3. In the case of 4, if you write, so obviously you will be having 4 data node available, then you will get the same exact copy in the fourth machine also, but you will not be knowing that in which machine it is going. If you have 10 data node and you give replication factor 4, so you can track this 3 replica, but fourth replica cannot be tracked. Okay, so this is why the replication factor is 3. If anybody asks you why replication factor is 3, you can answer this rack awareness concept. Okay, this is how we keep this data and data center and the whole hierarchy is working. When we say metadata, one more point which I forgot to mention there, name node. Here in this point we'll see why Hadoop is not good for a small file. Why Hadoop is not good for small files. We have seen this as a cons, and a small file, or we can say low latency data. If you remember what is a low latency and high latency, guys? Low latency is a near real-time data, and high latency is a historical information, right? So low latency is mainly coming from uh, ticket booking like IRCTC, flights booking, stock market, and historical data which you have already stored in your data boxes since many years, like 20, 30, 50, 100. Those data are high latency data. But why Hadoop is not good? Name node is keeping metadata. Name node keeps 150 bytes. This is the number which you'll have to remember. Name node keep 150 bytes metadata for each block. For each block. If you reread this statement again and again, you'll reach to one conclusion that name node does not care. Name node does not care what is the total size of data which you are keeping inside the block. Name node only counts the number of block. So if I'm copying 1 KB file, how many block? If I'm copying just 1 KB file, let's say this is an image. I'm copying this image in my Hadoop cluster. How many blocks will it create? If you guys could answer me, that would be great. If I'm copying 10 MB file, how many block? If I'm copying 100 MB file, how many block? So this is my image. I'm assuming this is my audio data. This is my text data. And I have 128 MB of log file. If I'm copying this data in my Hadoop cluster, how many block will it create? Perfect. So this will give me one block, one block, one block, one block. Because in Hadoop, we are working with a write once read multiple. It's not like that I'm writing this 1 KB in my Hadoop cluster and then again I can use the same file to append something, right? We know this point. Write once and read multiple. Once any file is written, it will just give us one block. But question is not this. Question is this. If there is just one block, reread my statement. Name node keeps 150 byte metadata for each block. For each block, which means they're not caring that 1 KB is there. So I will decrease the metadata for this. They do not care that this is 128 MB, this is 10 MB. They just care about the number of block. And since the number of block is 111, all file will have metadata. I'll show you this metadata. Okay, I'll show you this metadata also. 150 bytes, 150 bytes, and 150 bytes. What is an interesting fact here in this whole picture? The fact is, you're copying smaller file, but still the size of metadata is same. You're copying 128 MB file, still the size of metadata is same. So it's better to write the better file, a bigger file, so that your metadata load will be decreased. Because if you're copying thousand of 1 KB file, you understand how many metadata is getting created. So it is never a problem with the small data. Actually, it's a problem with the metadata as a reference point which name node keep for future reference. Whenever client request, actually they read this kind of information only. They read this metadata information only. Okay, that is the reason in Hadoop 1.x. That is the reason in Hadoop 1.x and in Hadoop 2.x. If I quickly compare how many file we can process in this and this. So Hadoop 1.x we can process maximum 1 million file. And in Hadoop 2.x we can process 1 billion file. Why? Why such? Because let me copy a 1 GB file in Hadoop 1.x and copy 1 GB file in Hadoop 2.x. Can you tell me number of blocks for each? In 1.x, my by default block size is 64 MB. This is my by default block size. In Hadoop 2.x, this is my by default block size, 128 MB. Okay. This is my by default block size in Hadoop 1.x and in 2.x. So here I'm focusing what would be my number of metadata in Hadoop 1.x and in Hadoop 2.x. So quick comparison, a quick calculation here. Good, Ritikesh. 64 MB if I divide, because my actual data size is 1 GB. If I divide 1024 MB, I'm just converting my GB into MB and 64 MB. You use the calculator to calculate this. you'll get to know the number 128 MB. How many block? 16 block. How many block? 8 block. But what did we say here? For every block, they are keeping 150 bytes metadata. I'll keep visiting this page, guys, because this is very important point. So 16 into 150 byte, 8 into 150 byte. Which one is a bigger? Where I am getting more metadata? Obviously, I'm getting more metadata in Hadoop 1.x. That is the reason they can handle less number of blocks. So when I say 1 million, this is what this many block we can handle in first generation of Hadoop. This many block we can handle in second generation of Hadoop, and answer is in front of you. Now you can say, okay, so if I see this number and increasing block size is decreasing metadata, so can I increase this to bigger number? Since they are configurable, if I keep, so I'll just take one number here of custom block size. So in Hadoop 2.x I'm working and I have configured my block size as 256 MB is equal to 1024 MB divided by 256 MB. How many blocks we will get, guys? 4 into 150. So if you see here, this is all decreasing number. Here my metadata is decreasing. But do not increase more than this number, your block. Do not increase your block more than this number, because this is a Google recommendation. And if you think logically also, if you keep 1 GB as a block size, then where is the distributed factor? You're not distributing your block properly. It is like you're giving 1 GB of whole data to one core or one CPU. Okay, because one core process this task. Whenever we will go to processing side, just one point to remember here: every core is processing individual task. So if I have one machine, okay, currently I'm referring my machine. So I have my node. This is my local machine. In this local machine, I have total 8 cores available. Okay, in this machine, I have total 8 core available that we call a 8 CPU, core processing unit. That's the reason we call that system is multi-core processor. What do we mean by multi-core processor? You have more than one CPU, and then we have some number of RAM, we have uh, some number of hard disk, right? This is what is our system configuration. What do I mean by this 8 CPU? That using this machine 8 a time, how many blocks I can process? I can process 8 block. I can process 8 block, not sequentially, in parallel. Getting me? That is the reason in cluster, what is a parallel processing, guys? So aiding all this bunch of machine, I have node 1. This is my node 1. I have node 2. I have node 3, and such that I have total number of node 40. Node 40. Total 40 machine I have, okay? And all this machine are having 4 core individually. So all node has 4 CPU. So in cluster, total number of CPU in your cluster, total number of CPU is 4 into 40. 4 core individual machine and 40 is the number of machine. So how many CPU is available in your cluster? This is nothing but a cluster, right? Cluster we call a group of machine. Cluster is a group of node. So that's what is a group of node. So I can process in parallel how many tasks total? I can process 160 tasks total. And why Google is not recommending to increase your block size more than 256? Simple reason I'll tell you. Okay, so let me write that as a note. Currently, our CPU, our CPU or system CPU can handle can handle or can process 256 MB of data effectively. Currently, our CPU, CPU mean I am talking about this core processor, can handle 256 MB of data effectively. I can increase, definitely, I can increase it to 5.2 MB also, 1 GB also. But if I increase to 5.2 MB, then my optimization will decrease. My performance optimization will decrease, hence it will take more time to process the data. And I will not be able to achieve the parallel processing. Right? If it is taking more time, what is the whole idea to come to Hadoop and work with the parallel processing concept? To complete your task as early as possible. But if you're not able to process your task as early as possible, which means I can say your cluster is not designed well. So this is all the cluster concept. This is whole cluster is designed by, as we know, administrator who are creating the environment. Okay. So 4 point, quickly recap about the name node. 4 point to discuss in the name node. First point, that they are the single point of failure, but in which version of Hadoop? In 2.x. Does that mean in 2.x we have multiple name node? So in 2.x, the answer is yes, we have multiple name node. So if one machine is having one metadata and second machine is also having the same metadata, if this goes down, we have the second machine available. From here I can read this information. For now, we'll see this two name node concept in HA. HA stand for high availability. So when we'll actually go to Hadoop 2.x and comparing start comparing 1.x and 2.x, that time we will see this point, high availability. High availability means you have the same information available in one more machine, which is obviously working as a master. So if this is down, the second can take care of the entire request or load of your cluster. That's the reason in 2.x you are not facing any downtime due to this point, that in Hadoop 2.x we have multiple name node available. This is one point. Second point, name node keeps all the metadata. Third point, name node is working with the replication, rack awareness concept. So why we have a replication factor 3? This is the strategic solution. Okay, I can increase it to any number, decrease it to any number, but this is a better number to work with the cluster. There's no foundation. Fourth point, that Hadoop is keeping 150 bytes as a metadata, and that is the reason in 1.x and in 2.x we can handle more number of data, and whole calculation is here. How we can calculate, and why we are not increasing more than 256 MB file? Because of this specific note. Any question here? If any question is there, we'll see. Otherwise, I'll jump to data node. All right, so let's go to data node now. I think this point is very clear now. So data node, only couple of points we'll see. Then we'll resume tomorrow what other services are doing. Data node, as the name itself is clear, that we will keep all the data in our machine, right? Point number first, data node sends data node sends heartbeat. Remember this terminology. Remember this terminology. Data node sends heartbeat to name node in every 3 seconds. Now, do you know what is a heartbeat? So heartbeat is like a message that I'm alive, I'm up, I'm active, I'm healthy. Okay. So that information is continuously going from all the data node to your name node. That yes, we are working, we are up, we can take any request. If name node, if and this is fixed, okay? This 3 second is fixed. If name node does not receive, if name node does not receive any message or any heartbeat till till 10th minute, till 10th minute, then name node consider, then name node consider that data node as date node, that data node as dead node. Can we reread this statement again? Data node sends heartbeat to name node in every 3 seconds. If you see my previous image, what is happening here? Client is checking all the metadata requests from name node. Name node provides this information as a form of acknowledgement. Client will start reading or writing the file, and this data node are in continuous talk with the name node. This is what this communication is, nothing but a heartbeat. This is a heartbeat. This is a heartbeat, right? So if data node does not send any heartbeat to name node consider that that data node is no more up. It's no more active in the cluster. And what they do, if they are unable to send any metadata, if they're unable to send any metadata till the given time, which is 10th minute, then name node will decommission this. Then name node will decommission this. So this is again the terminology we're using. Decommission means in English we can say remove. And obviously when I'm removing, whatever data is available in this data node must be lost. So suppose here I have 4 block. Let's just suppose in this data node I have 4 block copied. If this data node is I lost, which means I lost the 4 block also. But this 4 block replica is available here also, and the 4 block replica is available here also. Now what I'll do, I'll perform the commissioning operation. So commissioning operation means adding the number of node, which so I lost one data node. Now I'll add one more data node. So whatever block I have lost in this data node, the same thing I will copy using some Hadoop command, Hadoop balancer command to balance my cluster. So whenever you do decommissioning, you will have to perform commissioning. And decommissioning and commissioning, this thing you're only and only doing or processing with decommissioning, and commissioning is only the activity. Let me write it as node number 2. Decommissioning, which is removing your node from the cluster, and commissioning, and commissioning. Decommissioning and commissioning we are only doing with slaves. We are only doing with slaves. And answer why we are doing this with only slaves, this answer I will give it tomorrow, guys. Okay. So one point to check with a data node, that data node is continuous talk with the name node in every 3 seconds. If they are unable to communicate till this time, then name node will decommission it. And what is a decommissioning, commissioning, how we are doing that in detail? We'll see it tomorrow.